Pauling's rule number 2, talking about the strength of ionic bonds. Right. Now, stable ionic structures are preserved when there's a local electroneutrality. That means that once all of the ions are bonded together, the charge has a net zero charge, right? There is no overall positive, overall negative. They cancel each other out when there's an ionic bond. So the electroneutrality, zero net charge. Right? So this allows us to figure out, well, what does the strength of each bond have to be in order to create a zero net charge, right? So to achieve electroneutrality, for example, what must the bond strength of quartz be in SiO2? Now, to figure this out, we have to think about, well, what's the coordination number, right? 4. And what's the overall charge, the cation charge? 4. So in order for that to cancel out, each bond strength has to be 1, right? So 1 bond strength times 4 anions, right? That coordination number equals the charge of the anion. So to put this, to summarize this, the strength of each bond equals the cation charge, which in this example is +4, divided by the coordination number. In this example is 4. So we get a strength of 1 for each bond. Now we can take this a little bit further and start thinking about what this means. Well, what this means is that if you increase the cation charge, what does this have to do to bond strength? So look at this formula here, strength equals cation charge divided by coordination number. And think to yourself, if the cation charge increases, what happens to the bond strength? Well, it also increases. Now think to yourself, if the coordination number increases, what happens to the bond strength? Well, it decreases, right? So this is relating the strength of each bond to the charge of the cation and the coordination number, how many anions are surrounding it. So basically, Pauling's rule number 2 is that formula. It says the bond strength equals the cation charge divided by the coordination number.